Interesting hardware. This is the T1 UK wall mounted 2-channel joey to replace a light switch. I've already had a look, and the front panel comes off. You can see a board with programming header, got ground, transmit, receive and power. There isn't a GPIO 0 that I can see. We do have another connection over here. Maybe there's something on there. That's to investigate. I could look it up online, but I'd rather figure it out myself. Also, this has an RF receiver in it for 433 megahertz, which is one of the reasons I wanted this. Now if we pry the board up, see we've got relays down at the bottom. You can see the underside of the relays there. We have neutral in, live in, which comes across this gap here. There's a resistor bridging that, and then that's separated low voltage, high voltage, live in relays, space for another relay just there. It looks like we've even got the transistor and diode ready for the next relay, so the only component missing is the relay itself. Likewise on the top there's the LED and there's the pad for the third button. Got 3 transistors here, 3 resistors. Yeah, the pads are all connected there to the touch sensor. Assume the touch sensor is going to go back up here. This will be the RF IC. Before we get into the ESP and using that third channel, let's see if we can program the RF receiver. Let's turn it on. Now I took the wall apart and I was pleased to see, I took the socket off the wall. I was pleased to see we actually have live and neutral going down the wall. So I can put this in the kitchen and I don't have to walk through a dark room to get to the light switch. Okay, now this is a 240 volt supply, it's not the mains. It's my isolated bench supply. So let's turn that on. A little bit of flickering on the Wi-Fi LED. Reset button. Don't know what that resets because the light's still flashing. Now I believe these can be programmed to an RF remote by simply holding down that. Look at that. That was all completely out of shot. So it has a nice little blue glow and gets brighter when it's on. Probably works when that's clipped in. Find a remote I'm just programmed into it. Or learn how to erase the remote. It's in Chinese. So programming the remote, here's a little cheapo Chinese clicker, and we should hold or touch the contact. One beep, program. Same on this side. One beep, program. And I believe it can learn multiple codes and cope with multiple frequencies. So, out of curiosity, can it receive these? No. Maybe it's just programmed not to. It may be that the receiver is actually picking it up, but it's being rejected by the software. Or it could be that these transmit codes as though they had two buttons held down. Oh, well that's interesting, that works. I wonder what range it gets. Well, that's quite good. So it doesn't work with all transmitters. Oh, it definitely works with some. Well, that's good, because that means this has got a receiver and a chip that I can reprogram in the same box connected to each other, so I can use this to sniff signals for these while being a light switch at the same time. Excellent. So what I'll need to do now is figure out where the decoder is. I guess it's that. Or it could just be a really simple receiver circuit. It could be that transistor down there. Well, there's a crystal there. What's that crystal? Let's turn it off and have a look. Well, that's 6 megahertz. got this empty bit of track down here, empty bit just here. That's because the Wi-Fi aerial is on this side, and this is the 433 megahertz aerial. And that comes in capacitors, missing inductor, capacitor, capacitor, inductor into this IC. So I need to look that up and then find where that connects to that. Maybe that. Right, I've got my little toy oscilloscope, and the only probe leads I can find, so I need to attach a ground wire to here so that I can get a clip-on connection. I also need to find myself a 9-volt battery or something, because when I moved in the smoke alarms didn't have batteries in, so I put all my 9-volt batteries in the smoke alarms. Fun. Right, so there's my ground connection. Anyway, that's ready. Now I need a 9-volt power supply. Be right back. Right, I couldn't find a 9-volt battery. Everything's too efficient and runs on 3 volts nowadays. So what I'm going to be doing, I've got this connected up and I'll be having a poke around. I know that a lot of these decoder ICs run at 1.5 volts, so I've left this fairly sensitive. I'm going to be transmitting with this little bipper and then probing around looking for an output signal and then seeing where it goes on this board. So this is on a wall wart rather than a battery, but this is not going on the mains. I'm going to connect it to my isolated bench supply. I would not recommend doing this if it's plugged into the mains. So here's my power. Okay, let's see if we can find this signal. Going to guess it's one of these resistors on this side of the IC. Yeah, that's noise, that's data. Now it's a 5-volt signal. Okay. Either side, track here, all the way to here somewhere. Need more light. just going to turn this off while I poke around. Right, just to check we still have the signal down here. Yes, we do. But I can't find it up at the IC. I followed it all the way back to here. I can detect it on this track. It goes under the corner of this IC, but I can't find it coming out on the other side. So there must be a wire under there. There's no wire under there. Well, that was infuriating. After 20 minutes of trying to figure this out, I traced the pin, I traced the signal to here. See that little scratch on the track? That's where I was just probing to make sure I was definitely on the right track. I saw it disappear under this IC, which we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pins on. It appears to disappear under there. So it doesn't come out anywhere, and there's no wires. It's not this one on here. It's not this one here. So I eventually looked up the data sheet for this, and it's a 20 pin chip. It's got 4 more connections under the corners. So although we can program the ESP, we can't reprogram this. So we need to figure out what is between here and the ESP and see if it passes any data about the fobs or the RF signals that it receives, or if that's all done in this chip and then it just passes back a turn on turn off signal to the ESP. Or maybe it does, actually it does the turn on turn off, look, we can see it. So we need to figure out what the ESP actually does, if anything. Right. More reverse engineering needed. So after lots of chasing around, the signal from here, from the RF receiver, only goes as far as the corner of this IC. It's not passed across. The button presses and the RF button presses are sent from this little 51 based system here over to the ESP as simple presses. So not much I can do with that, but I've got the GPIO 0 there, I've got my programming port there, and I've put my own firmware on here. So I've now got the Wi-Fi LED on all the time. It just blinks when it's receiving command from either Zapper or a key press. And also, Alexa, turn on the kitchen lights. It's connected to Alexa. And this is without using the Sonoff app. One thing I did notice, these have got little clear plastic covers on them. So, take those off. It's left a static charge on, which has upset the touch sensor. Alexa, turn the dining room light off.